Hi, welcome to the Calculus 2 lecture series. And we are in the unit number 4, sequence of the series. And this is the second part of our lecture number 18 for the comparison test here. Okay, so on the video number 1 for the lecture number 18, we introduced the comparison test or the limit comparison test. So we know that by comparison test, if we find a certain series is a convergence, and now we go into the second part of the video, we're going to talk about if if by the comparison test we verified, we prove the series is convergent, then what is the estimated value? What is the error? When we try to estimate by using the partial sum, we want to estimate the sum of the series by using the partial sum. Then what will be the errors we are going to deal with that? Okay, so let's go ahead and go to our lecture notes here. All right, so in here, okay, let's go ahead. We said estimate the sum of the convergence series if we're doing by the comparison tests here. So we say if the an, right, summation n from 1 to infinity, if the an is equal to s, if this one we say this is a converge, okay, by the comparison, by the comparison test, if we find sum by comparing to using, we know the sum existing series n from 1 to infinity, and the bn, if we know this one is converging to t, and then we know whatever this series converging to, so the s minus sn, that's the partial sums, right? It's because this one here is compared by comparison test. We know if an is less than bn for every n, so that's why the bn converge. We know the an converge, so that's why this will going to be less than t minus what? T minus tn's, right? For the n is equal to 1, 2, 3, and . Okay, so what's that means here? That means in here, right? So that means t minus tn's here. So we say this means tn, right? So it's the reminder terms for the series summation bn. So the tn minus tn here is what? Is an upper bound, right? So it's the upper bound for an estimate of what? Of my remainder term Rn's here. Okay, so of course, just like we talked before, the video number 1, when we try to find the comparison test, so hopefully the series we used to compare to is easy, to find what the limit values compare, what is this series converging to, what is the value converging to, see here. Okay, so now let's take a look at this example, see here, right? So the example number 3 says, show this one converge by comparison test and find an upper bound for the differences between the s and here we are trying to find is the fifth partial terms here. Okay, so let's take a look here, right? So this one's here, this is 5 plus n, and this is n times 4 to the nth here. All right, so we said that when you try to do the comparison test, you want to find some series, we know it's easier for us to find the limits the series going to converge to, see here. All right, so now in here, by looking at this, Okay, so you kind of see this term is kind of short, like 1/4n. So I know if it's 1/4n, that is a geometric series. It's a pretty standard series and it's easier to compare to. So I hope that maybe I can find that this is a geometric series here. All right, so let's see here. So what I can do is here. So let's see. So if I keep here the n to the 4n here, right? And the 5 plus n, how do I change to something? Of course, here, what we want here is that we want this one, the less than equal to a convergent series. Okay, so for 5 plus n, think about it, 5 plus n equal to 1, you have 6, you have 7, 8, right, So that's what is the top values here going to be. So the 6, 7, 8, 9, 10, like when n going on. So obviously, this one going to be less than equal to, if I put here the 6n here, right? So when n is equal to 1, it's 6, but when n is equal to 2, it's 12. So it's greater than. So I know I can make this choice. The reason why I want to make this choice is here is because then I can cancel the n's here. So that's why this one will be equal to 6 over what? 4n's, right? And I know the series n from 1 to infinity, 6 over 4n. You can take the 6 out, right? So this is n minus n from 1 to infinity, 1 over 4n, correct? All right, so then what is this series here? This is what? So this is a geometric series, right? So this is a geometric series with R is equal to 1/4. Because R is less than 1, so I know this is what is a convergent series, right? So this is a convergent series. And also the geometric series, we know how to find the value of this series. So because this is R, so this yellow terms will just be what? 1 minus what? 1 minus 1/4. All right. So 1 minus 1/4, and here will be the 6th, right? Okay, so will be the 6 times 1 minus 1/4. All right, so let's see here. So this is a 6 to the, okay, so be careful here. Okay, so let's take a look here. So this series, like remember we said we always want to write it out. So this is a 6 to the 4 plus 6 to the 4 to the 2 plus 6 to the 4 to the what? To the 3, right? So remember here we say we want to factor the 6/4 out. So this will be 1 plus what? 4 plus 1 plus 4 to the square, So now here, this one's here. So this one's here by using the geometric. So this one is equal to what? This one is equal to the 1 minus r, right? So it's a 1 over 1 minus 1/4. So that's why the whole things here will converge into 6/4, 1 minus 1/4. So what is this value converging to? This value converging to 2. All right, so I know, so this value converging to 2. So then because this is a geometric series, so I know this one's here, n from 1 to infinity, 5 plus n times 4n. So what happens here? This is a converge. Why? By comparing to what? And geometric series, right? So we are comparing to a geometric series with R equal to 1/4. So that's why we know you compare to it, you compare to a convergent series, it will be convergence here. Okay, so now let's take a look. We said the 5th terms, right? So if for the series here, the fifth term, the t fifths here, that means I'm just adding this will be the 6/4 plus 6 to the 4 square plus 6 to the 4 cube plus 6 to the 4 plus 6 to the 4 fifths, right? That's the partial sum of this Bn. And this one, if you put it into a calculator, will be very close to 1.98805. Okay, so I know the remainder for the phi, t phi will be the t minus t phi. So will be what? We know it's converging to 2's, right? So will be 2 minus 1.98805. So these ones here will be pretty close to 0.00195. So I know the R phi will be equal to S minus S phi. The upper bound is what? So the upper bound is so the upper bound for this ones here is 0.00195, right? So I know the S phi, where is within the, so that's why if you use the partial sum of the S phi, so that's what we say, we know S phi is what is within, right? So it's within the 0.00195 of the unknown value. Whatever this series converge to S, right? So that's why we said this is the, so this is the within, that's the arrows could have, it's not, that's the within, that's the boundaries, that's the limits, right, for the unknown value S. Okay, so now let's take a look here. So like from the video number 1, we show this is a convergence, right? And also, if you remember, we show this ones here. This is 1/2n plus n. This is less than or equal to the 1/2n. So we know it's a converge to what? To a geometric series, right? So this one's here again, right? So this one's here, we know this is a geometric series with R equal to 1/2. Okay, so the first one's here. So let's say find S4s here. Okay, so the S4 is pretty simple, right? Just like n equal to 1. So this will be 2 plus 1 plus n equal to 2 will be 4 plus 2, and n equal to 3 will be a plus 3, right? N equal to 4 will be 16 plus 4. So I know the S4 here is what is 141 over, if I just calculate that is 220. All right, so I want to estimate the difference, the sum of the series and the partial sums here. So basically they want to estimate S over Sn, what will be the differences here. So because we know this is a converged tool, so this series here is 2n, n from 1 to infinity is a geometric, right? So it's a geometric series and with R equal to 1/2. So I know it's a convergent series. So let's write it out. So this is 1/2 plus 1/2 to the square plus 1/2 to the cube, So then you can take the 1/2 out, and then this is plus 1 plus 1/2 plus 1/4 plus 1/8, Okay, so be careful here. This is not 28. This is 1/2 to the 3rd, right? Okay, and then remember, right, by the geometric series, so we know inside here, what is this one going to be? So this one will be 1/1 minus what? 1/1 minus 1/2. So that's why the whole thing is going to be what? It's the 1/2 here, So it's 1/2, and then this one here is 1 minus 1/2. So I know the whole thing's approach to what? Approach to 1 is here. All right. Then to do the same thing, because this is my BNs, right? So I know the T4. So the T4 will just be 1/2 plus 1/4 plus 1/8 plus 1/16. So this one's pretty simple. If I add it up, it's 15/16. So I know S minus S4 is going to less than T minus T4. So the T minus T4 is 1 minus 15/16. So it's 1/16 here, right? So that's why we know, because from the part A, we know that S4 is equal to what? S4 is equal to 141/220. Okay, so we know this number is within 1/16 of the value S here. So that's how do you estimate, right? So that's how do you, so that is within the 1/16 of whatever this series converging to, right? So whatever this series converging to the true value of the S, we don't know, but so we can estimate. All right, so that's it for the second part of this lecture. Number 18, we talk about a comparison test. Then we also talk about, after you use comparison test and you find a series is a convergent, then we want to estimate, when you use the partial sum, try to estimate what the value the series is converging to. We want to see what, how close you are, what could be the, the bound you have, how close you are, right? So like for the number 4, we said, I know the S4, this is 141/220. The true S is within the 1/16, right? So it's a pretty good estimation. So it depends on how accurate you want, and then you can increase the number of the n terms there. All right, that's it. And now we finished the comparison test. Our next video, we're going to talk about alternating series. All right, have a good day. Okay, bye. Talk to you later. All right, bye-bye.